Hello students, good afternoon. So today we are going to see the design of series connection of solar PV arrays using MATLAB software. So myself Prof.R.Revathi, Assistant Professor in the Department of Electrical and Electronics Engineering, KPR Institute of Engineering and Technology, Coimbatore. So first of all we have to take the PV module, so as per these technical details. So these are the parameters we have to look into. So that is the rated power, voltage, current, open circuit voltage value, then the value of short circuit current, total number of cells connected in series, total number of cells connected in parallel. So first we have to take rated power. So we are fixing the rated power as 200 watts. So that is we are choosing 200 watt solar panel here. Then voltage at the maximum power is 26.4 volt. And we are obtaining the current at maximum power is 7.58 ampere. So we have chosen the open circuit voltage value of 32.9 volt and similarly short circuit current value as 8.21 ampere. Here the total number of cells connected in series is 54 and the total number of cells connected in parallel is 1. So here we are choosing series configuration of 200 volts PV array. So when we connect two 200 volt solar cells in series, so here the voltages are added, the current remains the same and power is the product of voltage and current. So this is the theoretical calculation of series configuration of 200 watts PV array. So here the total voltage is we are getting V1 plus V2 since the two voltages are added here. So V1 we have chosen 26.4 volt and we are adding 26.4 plus 26.4, we get the value 52.8 volt. And the current remains the same in series configuration of 200 watts PV panel. So the IT, that is total current, is equal to 7.58 ampere. The total power consumption is the product of voltage and current. So voltage is 52.8 into current 7.58. So when we are multiplying, we get the value of 400.224 watts. And as by Ohm's law, so R is equal to V by I. So V is Vt here and I is It here. So Vt, that is 52.8, It 7.58. So we are dividing. So we get the resistance. So just to open up MATLAB R2021. So I have the version 2021B. So just click Simulink. So you'll get the window Simulink and you create blank model. So in that click library browser. So in that, so we have to get the components. So type PV array and just enter. So you'll get the PV array. So just pick and place over here. And you or you can right click in that, click add block to model untitled. So this well suits. So then second parameter is power GUI block. So type power GUI and click enter. So you will get the power GUI block. So just drag it over here. So next we are in need of current measurement and voltage measurement. So in order to measure the current and voltage parameters, so just right click on this, add block to untitled. So similarly voltage measurement, right click on this, you click add block to model untitled. So you'll get this here. So next is we are in need of constant block. So go to library browser. So just type constant. So you'll get the constant block. So just pick and place over it here. So you need of two constant blocks. So just right click on this and click copy. So then paste over it here. So we have to give 1000 here. So click apply and then click OK. So again we have to give the temperature as input. So double click on this constant block. So type the constant value as 25 degrees Celsius. So just type 25 here, click apply and then OK. Then again go to the library browser. So we are in need of display block. So just type display here, click enter. So you'll get the display block. So display block is placed in untitled model. So here is your display. So just drag it over here. So you are in need of 3 displays. So copy and paste over it here. Then go to the library browser. You are in need of series RLC branch. So type series RLC branch and click enter. So you'll get the series RLC branch. Add block to untitled model. So double click on the series RLC branch. So change this branch type to R. Click apply and then OK. So now we are in need of connections. So this 1000 is connected to irradiance. This 25 degrees Celsius is connected to temperature. Then plus terminal of the solar PV is connected to current measurement block. Then this minus is connected to this R. So right click on the series RLC, click format, then rotate clockwise. Then minus is connected to one terminal of resistor. This solar PV minus is connected to other terminal of resistor. So always voltage measurement is connected across the block, across the resistor. And minus is connected to this terminal. So then we are in need of product. So just type product and press enter. We can place over it here. So this is to measure current value and this display is for voltage measurement and this display is to measure voltage as well as current, that is the product of V and I is power. So the connections are over. So just double click on this PV array. So we have to give the value. So here we have chosen parallel strings as 1 and series. 2 solar panels are connected in series. So press 2. Here cells per module is 54 as per the technical details of PV array, and open circuit voltage is here 32.9. So give the value of 32.9 volt and short circuit current of 8.21 ampere. So just type the short circuit current as 8.21 amps. So the voltage at the maximum power point is 26.4 volt. So just give the value 26.4 volt. Then current at maximum power point is 7.58 ampere. So just type 7.58 ampere. So then click apply and then press OK. So now simulate this and click run. So here we have run the simulation and we get the value of current as 7.583 ampere and we get the value of voltage as 52.78 volt, and the product of voltage and current is, that is nothing but power. So power we have obtained as 400.2 watts. So now compare this with the theoretical value of series configuration. So we get the total voltage as 52.8 volt. So here 52.8 volt, then current as 7.58 ampere. So we get the current as 7.583 ampere and power as 400.224 watts. So power as 400.22 watts. Okay, so this we have simulated in MATLAB software.